Assalamu alaikum everyone. I hope you are doing great. Today in this video, we are going to study about one of the most fundamental topics of microeconomics. Let's see the name. It is production function. So today I am here with you, Muhammad Tasnimul Haq, and second year business administration student from Shahjalal University of Science and Technology. So without further ado, let's start. So after finishing this video, what will be our key takeaways? First of all, we'll be having a clear understanding of production functions, and then we're gonna study about the different factors. There are two type of factors that influence production functions, such as fixed and variable. Then we'll study about the factor ratios, and then we will study about short run productions function and long run production function, and then we will study about one of the most important topic for the exams, which is the key differences between short run and long run production functions. So we're gonna start with production function. What is actually production function? It is a relationship between physical input and physical output of a commodity or product. So this might sound a bit difficult for some. We'll understand this concept with an example. Suppose you are a businessman and your product is pencil. So you make pencil and you earn money. So for producing pencil, what you're gonna have to have a machine, and of course machine and your industry, and you have to have labor, right? So in the production function, it studies about the physical inputs and output of production, like what will be your physical inputs in business. So your physical input can be the labor you have or the machinery you use to produce that pencil, right? And the output would be your pencils. So uh, if we are if we want to mathematically place the equation, it would look like this: qx is equal to a function of l and k, where l and k are the two variables of f function, and it is and the denotation of this function will be qx is the physical output of commodity. For this scenario, it is the pencil, and L and K both respectively denoted as the labor, unit labor, and K is mostly denoted for the unit of capital or equipment that it requires to have. So what in this function, it is not only that there will be only two variable. There are lots of other variable that can be in this place, like raw materials such as wood, or you can also have innovation or a new product, and some other lots of other factors. So these factors are called a factor of production. Moving on, now we will study about fixed and variable factors. So if let's let's analyze this scenario. You have an order of 2000 unit of pencil and 8000 unit of pencil, right? So in order to give this supply to your customer, you have your factors such as machine, factory, and then variable and factors. So there is an example, like one pencil maker machine can make 1000 units, means the range is 1 to 1000. You cannot go beyond this limit. Okay, so a machine, you have only one machine in your factory, suppose. So this machine can maximum can it can make output of 1000 unit. It's a fixed unit. You cannot suddenly bring another machine and use it straight away, right? So if you have an order to give, let's say example, for 1 week, it is not possible for you to bring or modify the existing machine. So machine is a variable, it is a fixed factor. Then come about your factory. You cannot build a factory instantly, right? So factory is also a fixed factor. But as for manual labor, you can obviously bring more labor in your factory and accelerate your production, right? So if you have it is if in an ordinary day you are producing 2000 unit and suddenly you have an order of 8000 unit, what you will do? You will bring more labor in your factory, and you will sharply increase your production to 8000 unit, and you will be fulfilling that order, right? So, as for the variable factors, let's read it out. Are those the application of which varies with change in volume or level of output? If the output is higher, we can change this variable, but we cannot change this one. Let's move on. So right now we'll study about the short-run production function. So it is a period of time when production can be increased only by increasing the application of variable factors while fixed factor remain constant. So we can increase the production function to that extent where we will not uh, alter the will not have that much time to alter the fixed factors. So in this case, for the pencil thing, we can only increase the number of labor. Okay, we have let's assume we have currently 5 labors. We have a machine that capacity is 9900, and in that case we can not increase the machine and we can increase the labor. So production capacity remains constant during the short run period, but the variable factor is shown change. So this is an important thing. If you have only one machine and it can produce maximum of 9900 unit, you cannot go beyond that any way possible, right? If you are not bringing another machine. So that's why in that's why in short run production, capacity remains the same. So if you have an order in this scenario of 4000 unit within a plant, can you take the order? The answer is no, you cannot take this order. So in production functions, the function L is changeable and the K is not changeable. That's why K, it is denoted as K star. K star refers to the value is constant. Now we'll study about long run production functions. So in long run production functions, what happens is we have a period of time that all the factors can be increased to meet that target. For example, you have an order of 4000 unit order within 2 years. Okay, 2 years, that's a long time, right? So in 2 years you can, if you have the money, you can bring another machine, you can build another factory, and you can meet that target. So that's why if you have a 4000 unit order for 2 years time, you can take the order. Okay, so there is an important line here. Production capacity can be increased by altering the factor during the long term production. And another thing we have to acknowledge that we can mathematically also place that equation like we have done it here. On the next slide, we're gonna see the factor ratio. That's an important aspect. So there are two type of factor ratio, like constant and variable. Variable for the short run and constant for the long run. Let's understand this with this slide. We have a two equation on both the sides, and there is a graph for the variable factor ratio. It's typically happens in short run, and here we have an equation let's look at this equation. The ratio, factor ratio means L1 by L2, K1 by K2. So in this case the factor ratio is 5 is to 1 and 10 is to 1. So as the production is increasing 4400 unit to 800 unit pencil, the factor ratio changed, and on the end, if you see this graph, the the increment is on the parallel to the x-axis and constant of the y-axis. So it is not in this axis, the capital is not actually increasing anymore. So the more labor we are bringing on the factory, the more we are getting the output. But there is a twist here. It is not always the same thing happens. We'll learn about it in some other video. As for the constant long run, constant factor ratio, it is basically happens in long run production. And the let's have a look at this equation. There is 400 and 800 unit of pencil, and you can see that on the first equation it is 5 is to 1, and on the I think there is a mistake I made. I apology. There would be 10L and 2K star. Okay, so how is that going to happen? In constant factor ratio or long run, the factor of ratio changes equally as the output increases. So think about it, 4,000 to 8,000, what it is doubled, right? So then in that case the labor will also be doubled in the second scenario, and the machinery will also be doubled. So the ratio will remain exactly the same. So the factor of ratio changes equally as output increases. So the rate of increase is equal to the rate of factors. Okay, so production increment is equally from the ray of origin. So in this graph, this is a ray from the origin, and the distance between k1 and l1 and k1 and from this distance is equal. And we can measure the rate by doing the ratio of these two. Let's move on. The differences between production functions. So in short, we can identify the three main difference. So first of all, short run is identified as variable proportion type function, and constant long run is identified as constant proportion function. The reason has been discussed earlier. There are two other things like scale of output is constant in short run, and scale of output is changes in long run, and exhibits return to factor. Short run exhibits return to factor, and long run exhibits return to scale. Now the thing is, what are these two things? Let's understand in a very simple manner. What is these two? What are these two? So return to factor is basically the when you have to increase the production, you go back to the factors, and you change the factors, right? Like labor, raw material. When you are changing that, it is the concept of short run production. And in the case of return to scale, scale refers to the machines, or that is something like equipment. So in that case, it can be also can be fixed factors like land, capital. So return to scale is a concept that is used in long run production. There are basically three type of production, like increasing return to scale, decreasing return to scale, and diminishing return to scale. So we will understand one by one what are these actually. Okay, so we have brought a lot of labor phases here, right? Why? So because of understanding this thing. So we have one machine, okay, in the factory. I have three labor in the factory. So in that case, it will I have there was only one labor, for example, in the primary set. I have brought two other labor in the factory. In that case, obviously the production will increase. If I am bringing, I have now on the second instant, I have bought about two double the labor numbers. I have bought six labor, but in this machine, maximum three people can operate and produce goods. The other three will cannot help but sitting around, right? So that's the machine's capacity. For example, you can have one laptop, you can have two people, one is probably typing and another one is looking after the time. But in the case you are bringing about four people and they are working on one laptop only, then the efficiency will drop, and the people you bring, two other people, they will only sit around and they will have nothing to work, right? The same concept is here. The more people you are bringing in, there will be the output will be lesser, or the increment rate of output will be less. That's why there is a concept of diminishing return to scale. That means that there will be a point when the more labor you bring, the in the efficiency will drop. So this is the scale factor. So I think we have garnered a bird's eye view of production functions. There are lots of other topics that we could discuss, but due to time constraint, we thank you for your time, your patience, and I also want to acknowledge and thank our honorable sir, Dr. Muhammad Sadiqur Nabi Chaudhary, for giving us this platform to explore new topics and share this knowledge with you. So thank you very much for watching, and if you like this video, please like, subscribe, and hit the notification bell. We'll see you soon. Thank you.